Peace be upon you, my dear students in grade 11. Today we will start by a new lesson called Polynomial Functions. This lesson is divided into 5 parts. Objectives. At the end of this video, students will be able to study the parity of a function, study the sense of variations of a polynomial function. Before you start, please prepare the following materials: textbook, pens, draft papers, copybook, calculator, and ruler. At the beginning of this lesson, we will revise the definition of centered interval at 0. An interval I is centered at 0 if for every x belongs to I, we have minus x belongs to I. Example, minus 3 is centered at 0. Why? Let A be a point of abscissa x, and A prime be a point of abscissa opposite to that of A, which is minus x. If x, the abscissa of A, belongs to minus 3, then minus x, the abscissa of A prime, also belongs to minus 3, as you see. Similarly for the other examples. Application. Choose from the following intervals a centered interval at 0. Please stop the video, then solve this application. The correct answer is minus 8. Why? In the interval minus 4, 4 belongs to this interval, but minus 4 doesn't belong to it. In the interval minus 2, 3, 2.9 belongs to this interval, but minus 2.9 doesn't belong to it. In the last interval, 7 belongs to this interval, but minus 7 doesn't belong to it. Now, we will start by the first objective in this video, which is the parity of a function. Do you remember what is meant by parity of a function? Correct. The parity of a function means whether this function is even or odd. In grade 10, we took two definitions. Definition 1. A function f defined on an interval I is even if I is centered at 0, f of minus x equals to f of x for every x belongs to I. In this case, y-axis is the axis of symmetry of the curve of f. Example, let f be a function defined on minus infinity plus infinity by the following expression. Show that f is an even function. First, we must prove that the interval I is centered at 0. Here, minus infinity plus infinity is centered at 0. Second, we must prove that f of minus x equals to f of x. Let us start by f of minus x. That is, we must substitute x by minus x to get x power 4 plus 4x squared plus 3, which equals to f of x. The two conditions are satisfied, thus f is an even function. Application. Please stop the video, then solve this application. Let us see some curves of even functions. Parabola. As we said, the y-axis is the axis of symmetry of the representative curve of an even function. The symmetry of any point on this curve with respect to the y-axis is also a point on this curve. So the y-axis is the perpendicular bisector of the segment joining the point on this curve and its image. Similarly for the other curves. Definition 2. A function f defined on an interval I is odd if I is centered at 0, f of minus x equals to minus f of x for every x belongs to I. In this case, the origin O is the center of symmetry of the curve of f. Example, let f be a function defined on minus infinity plus infinity by the following expression. Show that f is an odd function. First, minus infinity plus infinity is centered at 0. F of minus x, that is, we must substitute x by minus x to get minus 2x cubed minus 4x. Take minus as a common. You will notice that inside this parenthesis, this expression equals to f of x, which means that f of minus x equals to minus f of x. Thus, f is an odd function. Application. Please stop the video, then solve this application. Let us see some curves of odd functions. As we said, the origin O is the center of symmetry of the representative curve of an odd function. The symmetry of a point on this curve with respect to the origin is also a point on this curve. That is, the origin O is the midpoint of the segment joining the point on this curve by its image. Similarly for the other curves. Application. Let f be a function defined on minus infinity plus infinity by the following expression. Study the parity of f. 3 students solved this application at the board. Jad, Jude, Jawad. Let us see their solutions. Jad's solution, Jude's solution, Jawad's solution. Which of these students answered correctly? Please stop the video, then solve this application. Jawad answered correctly. Application. Let f be an odd function defined on minus infinity plus infinity. Complete the curve C of f. 2 students completed the curve at the board, Jad and Jawad. Which of these students completed the curve correctly? Please stop the video, then answer this application. The origin O is the center of symmetry of the curve drawn by Jad. The y-axis is the axis of symmetry of the curve drawn by Jawad. But don't forget that the function is an odd function, so Jad completed the curve correctly. Now we will talk about the second objective in this video, which is the sense of variations of a function. This means that is to determine whether the function is strictly increasing or strictly decreasing according to the values of x. In grade 10, we took 2 definitions. Definition 1. Let f be a function defined over an interval I. F is strictly decreasing on I when for every 2 real numbers x1 and x2 of I, such that x1 less than x2, we have f of x1 greater than f of x2. This graph shows that on minus infinity 0, the function is strictly decreasing. Let x1, x2 be 2 real numbers belonging to minus infinity 0 such that x1 less than x2. So x2 minus x1 is strictly positive. F of x2 minus f of x1 is strictly negative. If we divide these quantities by each other, we get negative. So don't forget that f is strictly decreasing. F of x2 minus f of x1 over x2 minus x1 is strictly negative. Definition 2. Let f be a function defined over an interval I. F is strictly increasing on I when for every 2 real numbers x1 and x2 of I, such that x1 less than x2, we have f of x1 less than f of x2. This graph shows that on 0 plus infinity, the function is strictly increasing. Let x1, x2 be two real numbers belong to 0 plus infinity such that x1 less than x2. So x2 minus x1 is positive. F of x2 minus f of x1 is also positive. Then the ratio of these quantities has the sign positive. So don't forget that if f is strictly increasing, f of x2 minus f of x1 over x2 minus x1 is positive. Now, our goal is to learn a new way to study the sense of variations of a function other than that in grade 10. We know that the sense of variations of a function depend on the sign of f of x2 minus f of x1 over x2 minus x1. By replacing in this ratio x2 by x and x1 by a, we obtain f of x minus f of a over x minus a. F of x minus f of a over x minus a and its limit have the same sign. But do you remember what does this limit equal to? Yes, it equals to f prime of a. Thus, the sense of variations of a function depend on the sign of its derivative function. As we said, the sense of variations of f depends on the sign of f prime of x. That is, f is strictly increasing if and only if f prime of x is strictly positive. F is strictly decreasing if and only if f prime of x is strictly negative. Example, study the sense of variations of the function f defined by the following expression. First, we must determine f prime of x, which is equal to 2x plus 2. Second, we must determine the roots of f prime of x, which is minus 1. Third, we must set up the table of signs of f prime of x. Here, since f prime of x is a polynomial of degree 1, on minus infinity minus 1, f prime of x is negative, so f is strictly decreasing. On minus 1 plus infinity, f prime of x is positive, so f is strictly increasing. We can write the answer in other way in the form of a table. Here we have the table of signs of f prime of x, and we will continue the table by using arrows. Since f prime of x is negative, f is strictly decreasing. Since f prime of x is positive, f is strictly increasing. And finally, we will substitute minus 1 in x in the expression of f of x to get minus 2. Application. Study the sense of variations of the function f defined by the following expression. Please stop the video, then solve this application.